2023 here at Troopers. I'm Chris. I will be your host for today and tomorrow. And please welcome with me Yvonne and Fabian from Onapsis. I'm very happy that they are here again. And I thought about it. We have quite some history with Onapsis in the Troopers context. And I think it was the first time, when was it? 2011? Something like this. So they are basically a Troopers veteran, and I'm pretty excited about their presentation. So without further ado, the stage is yours.
Thank you. Welcome everyone. Thank you to attend to our talk. So the title today it's Adobe and SAP, all your business documents that belong to us. And maybe instead of explain what is the purpose of this talk, we think like a first little video demonstration can be speak by itself. So this is like an end user, the user SAP system. It's connected to an SAP system, and it just do a daily works. And what is hard, it just add like a new line in the table, so with a name, surname, and blah blah blah. Everything it's affect data, so we do not leak any salary of anyone. So it just enter a new line, and it print version. So you just click print version. And what it means like export my table as a PDF. So as you can see, right, everything works. The user has this PDF. Okay, realize, I failed on the city, you know, this is not Tokyo, David is from New York, or Seattle, normally, but yeah, it just changed something. Come on, end user, come on, yeah. And he wants to print again the print version, so he just wants, again, a new PDF export. This time, look like something weird happened. So as you can see, there a new page, something not expected. Also the salary changed a little. And if you see, there are one file attached to the PDF. And it looks like completely transparent. So basically, the talk today, we will try to explain what's happened behind. So clearly, the user was attacked. And so the talk is, we will try to explain what is behind this. So, hello everyone, my name is Yvan Genuer. I work for Onapsis. Onapsis is a security company, company dedicated to ERP security, so of course we work a lot with SAP. I work on SAP for more than 20 years now. And yeah, so that's me. We do a lot of research, pen tests, with Intel, etc., etc. And I'll let Fabian present himself.
Yes. Thank you. Does it? Oh yeah, it works perfect. So hi everyone. My name is Fabian. I'm also a security researcher. I actually do not get close to the 20 years of experience, but I also work in the SAP space now for quite some time. And yeah, I think we're both happy to be here today and give you some insights into our work on what turned out to be a really interesting component in SAP system landscape. And our plan for today to make you understand what actually happened behind the scenes of the demo video you just have seen is this agenda. So basically we start with a quick introduction and the state of the art, also showing our motivation behind this work. And then we actually go into our deep technical analysis, which will be the main part. And then on the exploitation side, we will actually show you the counterpart of the demo video you have seen from like a different perspective. And then at the very end, we will provide you with the means to protect against the findings we're going to discuss today. And then we conclude the talk at the very end. So, yeah, without further ado, I will hand over to Yvan again to kick off with the introduction.
Yeah, thank you. So, as an introduction, we will try to explain how everything starts. For this one, everything starts with a SAP pen test. So we perform some SAP pen tests sometime, and so the first question, SAP pen test, what is SAP? Who don't know what is SAP here? Raise your hand. Everyone know SAP. Good. I win like 2 minutes. So So, of course, if you want few number, etc., just go to this reference, you will realize how it's huge. And just one word, because we like to say it, is for us, SAP, it's like the backbone in the business process on a lot of companies. So, okay, continue direct to the point. So we were in the middle of the pen test, not in the middle, at the beginning of the pen test, to be honest. And we discovered this HTTP entry point. So this is like a web services, and the name was WSLV PDF. During the pen test, we didn't know what was this, so, but okay, and we just keep in mind, okay, this entry for maybe next subject of research, because during the pen test, we compromise the system with different way. The thing is, few months later, we do another pen test for another company, and this time we already compromise one system, and we try to do what we call lateral movement. So we go to the connection and everything, and we find this, it looks like there are one system, SAP ADS something, and you can communicate with Adobe Document Services. And again, it's ring the bell and let's start, hey, what is this Adobe Document Services? Because it looks like few systems are connected, etc., etc. So at this time, at the very beginning, we don't know what is this SAP ADS. But what we realize is, okay, it looks like centralized system. So a system that is communicate with a lot of other systems. It looks like it works with PDF, Adobe, stuff like that, so okay. So yes, today we will speak about how we work with how SAP handle Adobe Document Services. So that's very quick introduction, and for the state of art, I will let Fabian continue.
Yes, so first of all, we basically wanted to know what general document and form processing technologies are available in the SAP ecosystem. So we did a little bit of research into this, and it turned out that mainly you have these three solutions you see here on the slide. So the oldest of which seems to be SAP Script. That one already allowed not only to do basic stuff like page breaks, but also integrate your form templates with custom ABAP coding. So it already allowed a lot of things. And then afterwards, what came is called Smart Forms. And if you notice in the first bullet point, it says that this is something released with a specific version of R3. And if you work in the SAP domain, you probably know, okay, then this is probably something which is also already quite old. It had some advantages, just to name one of them. Besides processing or creating documents for printing purposes, it also allowed for HTML output, so you could build your interactive web forms with that, with the SAP Smart Forms too. And then there's our target for today, the Adobe Document Services. And as Ivan already teased, this is a solution developed jointly by Adobe and SAP. And it seemed to be the most recent solution, at least when it comes to the on-prem world. So we will see some alternatives at the very end of the talk, but yeah, that's basically ADS. And when we looked a little bit into, to find documentation on it, we also realized that it is known under different names as well, and especially a huge difference to the other two solutions I just have shown is that ADS is running in a Java runtime environment. So this could be, for example, the SAP NetWeaver application server Java. And ADS comes with a lot of different features. You have also security critical features like digital signatures, for example, but that was not something we looked at during this talk. For us, what was the most important fact was that you can use ADS in your system landscape to integrate both Java and ABAP systems. So this could look like the following. So this is what is known as central hub deployment of ADS. And here you can see that you could basically use this solution to have all your SAP systems make use of ADS for generating and rendering documents and PDFs. So again, this was something which caught our attention. So we tried to understand what previous research has been done on this component, and what other vulnerabilities have already been found. So we looked at the SAP security notes on ADS. And as you can see here on the slide, this is basically what we found. And you may, first of all, notice that the vulnerabilities or the patches here are, first of all, quite old, right? So the latest was from 2017. But also when we look deeper into them, it seemed like most of them are like related to dependencies of ADS and not specifically some issue in ADS itself. So again, another sign for us that maybe it could be worth it to do our own, like, more comprehensive technical analysis of this component. And yeah, that's basically what we want to show you today.
Okay, so now let's jump directly in the biggest part of this talk today. It's how we work on it, most of them. So we separate this part, we separate in few subparts. The first one, we call it like the first finding. So, and also the title XFA, but yeah. Remember, this is the web services we find during an SAP pen test. So we're back to our labs, and we try to, we were curious about, okay, what is behind, what is the purpose of this web services. After a moment, we understand that, okay, we can use what SAP call ALV table. So you are on, for example, connected on the Java system, and you can have this kind of table. This is exactly the same example table we use during the opening demo. And if you print version, you have a PDF export. At the very beginning, it's not working in our lab because we realized that, oh, we need to configure the ADS. So we did it. It's very simple. And at the end of the day, we are able to have this PDF. Okay, great. So we start to sniff what's come to the web services, etc. So we are something like that. So as a researcher or normal user, I'm connected to a SAP system. So this is what we show on the left. And we see that, okay, they communicate with the WSILV PDF. So this is the web services we discover. And then the web services communicate with Adobe Document Services. As you may notice, we create a box with SAP ADS on the bottom right, and the WSILV PDF is not a part of the ADS. We realize that it's a part of Java NetWeaver, the BI component. So just imagine that this WSILV PDF, this web services, can be on other system, but the chain is the same. You can connect to one subsystem. If you want to export as a PDF an ALV, communicate to the services, and the services can communicate to another system. To make it a little more simple, because you will see this is not so simple, we just say, like, just imagine it in the same system, you have the web services. All right. The first finding, so just imagine it, we are on the first day, we sniff what's happened, etc. from all the communication. And the first thing we find, there are no authentication for the communication to the web services. It means, as a researcher or an attacker, I can directly communicate with these web services. And what kind of data you need to send? It's XML, and we realize that it's Adobe XFA. So what is Adobe XFA? It's also pretty old stuff. To be very, very simple, it's XML based, and you send XML to generate PDF form. So inside the XML, this is where you can say, hey, I want this field, I want to use this font, I want to have this table, etc., etc. All right? So we do homework, and we go to the documentation, and we discover that this XFA can accept script tag. So in this XFA payload, or in this XFA, you can use script, JavaScript or FormCalc script. Again, I will not go deeper. We do not have like 5 hours in front of us, but FormCalc, it's basically some simple JavaScript, but more dedicated to do some math inside the PDF generation itself. Anyway, so the first finding was that. we find an injection in the XML XFA formula that you can send to the web service side. So we find an injection, and one kind of injection we decide to test is, hey, let's inject a JavaScript, all right? And most important, there are also, this is in the documentation of the XFA, you can mention like, I want to run this JavaScript on the server side. Because you can also decide to run the JavaScript on the client side. It can be wrong. But anyway, in this example, what we try to do is to try to have the version of the system, etc., etc. So if you send this XFA with this kind of injection, you receive a PDF with the result. So we get some information about the target. It's without authentication through one HTTP request. So we were very exciting because it could be, what can go wrong, especially because on the form calc, there are some URL, let's say URL type of request. So you can do post, get, put. So at this time we are like, whoa, very, very interesting. But unfortunately or fortunately for ADS, all the methods that use this URL stuff, so post URL, put URL, do nothing. They are completely empty. So yeah, at this point, we do not let's say, find a good exploitation of this injection. But just imagine it, we find it like in one day. So it starts to process, and we say, okay, it looks like very interesting, because if in one day we can find this kind of injection, what we can find if you start to go deeper. So this is what we decide to do. All right. Now the first challenge is how it works, how ADS works. Because currently we are like that. We send something, okay, it's ML, but inside the ADS box, it's magic for us. So, and also the second thing, it's if you are connected to the system, we find also a lot of function module to test the ADS. So we see some communication directly to the Adobe document services from a NetWeaver system, an ABAP NetWeaver system. And in this case, they use authentication. So we have these two, let's say these two entry points, the XFA process and the normal communication. So what we do that. We monitor everything. We monitor the process, we monitor the file created, we try to monitor all the network interfaces, etc., etc. So we launch all the scripts, and we start to test, to create few PDF, to test some injection also in the XFA, etc., etc. And at the end, we get like megabytes of data. So we start to analyze what's happened behind the scene to try to understand. And this is a simple representation of what's happened. Trust me, this is a little bit more complicated like that. But story short, what we would like to highlight here is there are three things. The first thing, so now just focus on the ADS part. The first thing is that when you ask to generate a PDF, so you send the XML and the XML is forwarded to the Adobe document services, it uses XML form. But how it started by execute, so it's implemented in Java, and it starts to launch XML form.exe. This is a bash script. .exe, thank you. And so this bash script executes the XML form binary at the end. And the XML form binary, it's the process who managed to generate the PDF, all right? This is what it's important to understand. Secondly, we find that there are several communications through the file system. So the XML form was able to write the PDF. So when you ask for a PDF, the XML form generates the PDF, then it writes the output somewhere on the file system. And the Adobe document services grab it and send it back to the user. For us, it's how to say that? It's high our curiosity again, because it means this XML form could be powerful process. He was able to write on the system, to read on the system, so it looks like something we would like to look. And the last one, but not the least, is we find, on localhost, we found that we use IIOP communication over the network. So it looks like the Adobe Document Services use the IIOP protocol to communicate with the XML form, like, hey, do that for me, or etc., etc. And we were surprised, to be honest, to see this kind of communication. And especially this IIOP protocol, we figure out that it's possible to communicate also remotely. At this time, this is only what we have. So now we just focus a little of what is this box, IIOP stuff, and I'll let Fabian to try to explain it.
Perfect, thanks. Yeah, so to quickly sum up, what we figured out was that internally, SAP ADS is quite complex, right? It involves a lot of components, but what definitely stood out was this IIOP communication that we observed. Not only because it's a protocol that we not see on a daily basis, right, like compared to HTTP or other protocols, but also because it involved that XML form binary, which seemed to be a crucial part of the entire architecture. So we tried to get a little bit more context around this IIOP protocol and what's behind. And what we figured out that this is actually related to the so-called Common Object Request Broker Architecture, or short CORBA. And CORBA is basically a standard developed by the Object Management Group. And what you can see here on this slide is a really, really high-level view of what this reference architecture here looks like. So CORBA basically says you have different software systems which could be written in different programming languages, and they can communicate with each other and exchange information about objects. So basically we have an object-oriented model, and for example here you could have a client which is an entity that wants to execute some operation of an object. And to do so, what it uses here in the middle is the so-called Object Request Broker, or short ORB. And this seemed to be a central part of the CORBA architecture because the ORB handles a lot of things like managing the communication, but also maintaining object references. So the entire call from the client side is completely transparent in that manner. And besides the architecture, the standard also defines a protocol so that ORBs can interact with each other. And the IIOP protocol, or communication we found here, or Internet Inter-ORB protocol, is basically the TCP/IP implementation of this. Now, when we get back to our target here and how this is implemented in SAP's application server, we first have to understand where it is implemented, right? And for that part, we can take a look at how a Java instance looks like on the right-hand side. And most importantly, the first thing is that we have the Internet Communication Manager, or short ICM. And the ICM is a binary or service that provides means for general communications with external systems. And you can speak HTTP with that service, but you can also speak IIOP with it. And then when we look beyond the ICM, we see that requests are distributed through what is called the fast channel architecture to specific server processes. And they then run the actual Java code. And we found most of the parts of the CORBA interfaces here being implemented in the free packages you see right there. So we found not only the low-level packet parsing in classes of these packages, but also standard ORB services, as we will see in a sec. And then finally, there is the binary, the XML form binary, which seemed something specific to ADS. And as we've already mentioned, we noticed that there was a communication going on between this binary and the Java backend through the ICM. And this communication was like in both directions, right? So not only the XML form speaking with the Java backend, but also the other way around. And the first thing we noticed when we inspected the system calls we traced previously was that when the XML form binary is started, it received some hex data. So what's highlighted here on the screen is the hex data we have seen, and this is actually something that is defined in the standard and that is known as an interoperable object reference, or IOR. And an IOR is It's basically a data structure which contains different parts. So first you have a type ID or repository ID, which is like an identifier for the Corba interface. And then you have a set of profiles. And the standard says one such a profile allows you to drive an entire invocation. So you have transport information like the target host and port where you can send requests to, but also what is called the object key and what will be a very, very important target for the next or the further analysis. But first of all, let's take a hex dump of the IOR that was passed to XML form. And what we can learn from that is, first of all, we can see that the XML form probably uses some Corba interface, which is known as the Adobe Service Manager, or the Manager Corba object from now on. Then we learn that this Manager Corba object is probably provided through the ICM IOP service pod. So that's just an example host here, but it's basically the ICM IOP service. And then we have that object key, which at first glance looked a bit random, and after further tests, we thought maybe it's not that random. But what's all about that object key actually, what it is used for? So we got back to the standard, and the standard says something that the object key is like a value that uniquely identifies an object. So for us, this was like an implicit access control. We somehow needed to get this key to also get access to the Corba manager object, right? So what we did, first of all, was trying to understand how this key is generated in SAP's Corba implementation. And we did so by doing a code review, and this is what we found. So this code snippet shows the method generating this key, and we can learn that the key basically consists of 3 parts. So first of all, we have a server ID, which is like an identifier for the Java instance. Then we have a timestamp in milliseconds. And finally, we have what today we will call the object counter. And this is something, as you can see, which is an incremental value. So this is how the object key is structured. Basically, we have a static part with the server ID, and then we have also dynamic parts with the object counter and the timestamp. So here you can see a packet that we captured from the communication between the XML form binary and the Java backend. And what you can see is that this object key is actually included in the request header, right? So this is a sample packet. And what we can also notice here is that the XML form binary makes use of that manager Corba interface to call a method called or operation called the getConfig property string operation. But for us, what was even more important, and maybe you notice it, there is no other kind of authentication material here, right? It's just that object key, which seemed to be something really interesting, because now we thought, maybe when we can get that key, maybe we could also inject ourselves somehow into this inter-process communication that is going on here. So our first idea was, okay, how we can get that key? Maybe we can simply ask the system if it can provide us with that key. And maybe we can do so remotely. So the first thing we noticed here was there is a standard ORB service called the name service. And this service provides access to a list of known operations, and you can use it to basically access a tree-like structure where you have all of the object bindings. So our idea was maybe we can get a reference to that naming service, and then we can just ask or search for that key. And to do so, we use a little script, as you can see here. This is our IOP chat script, which is aligned with the reference implementation we found. And it's basically our testing script. And when we executed this remotely, it failed. So we received some error messages saying that the communication failed. And it was weird because actually when we tried to do the same locally, it worked. And we were able to get an initial reference to the naming service. But remotely, it failed. So we had to understand what's going on here, right? And the first thing that we noticed at this point was that there was actually a vulnerability found by Ivan quite a couple of years before. And back then, this was actually a server-side request forgery issue. And SAP patched this issue by introducing specific allow lists. And when we check the coding again, where the IOP packets are being passed, we notice that at the very early beginnings of our of processing our packets, there are some methods which handle what is called service contexts. And a service context in the IOP data is something like a hidden parameter that can be used by the receiving ORB if they need like more information on some data or some implementation. And we can see here that when we enter the method that actually processes the service context included in the packet, it checks for a specific context with ID number 6. And in case that one is available, it enters the method where it actually maintains or enforces these allow list checks. So what can we do here? Our idea was when we look at our packet, maybe we can find that service context, and that was actually the case. So this was something which was implicitly added to the packets by our testing application. And when we looked at this standard, we understood that there are a lot of known service IDs, and our first idea was maybe we can just simply remove that part or change it because maybe we don't need it for our purposes here. And that actually worked. So we bypassed this new security control, and we were now finally able to work with that naming service remotely, which was good. So finally we were able to interact remote with that service. However, when we tried to resolve the manager cobber object via this naming service, it didn't work. So it seemed like that this object is somehow not registered at that service, or it produced some errors and we were not able how to proceed at that point. So our idea was if we cannot ask the service here for getting that object key, maybe we need to guess that key. And for that part, I will hand over to Ivan again.
Yeah, why? Every time we speak about brute force, it's for me. I don't know. All right, so the services, we did not find a way to, let's say, having this object key, but we understand how it's the format of the object key, and so the second feeling like maybe it's brute forceable. So this is the format we already showed. So in green, this is the server ID, the object counter, etc. So first I get the server ID. The server ID is something like we call it static because this is something we send one request, for example, the naming service we showed previously, and in the request we get back, in the package, we have the object, I would say that a part of the object ID of the services, but we, as you can see, we have the server ID, and the server ID is the same for all instances. All right. So it means you send one packet, you receive this kind of packet, and you have the server ID like that. All right. This is not the all for. This is not the same. This is different for all instances, but it's something very easy to have. So server ID, it's easy. We send one request, we have the server ID. So first part of the key. For the second part, this is what we call the object counter. So what is important here, it's a little bit more complicated. At the first time, we say, okay, we can brute force it. This is 1 byte, all right? So maybe we can brute force it. But the problem is after, we need to brute force the timestamp. So if we start to brute force the timestamp with the object ID also, it could be increase the timing a lot. So we try to find a way to guess it more. So again, we use our IIOP chart, and if we try to resolve these services like that, we go to the code. I will not go deeper. The main thing important is, okay, we reach the result, then an exception, etc. To, at the end, we get the object ID. We reach the part of the code where it just creates a new object ID, but for the naming services, not for the Adobe Document Manager. Okay, this is very important. All right, we send this from IOP chat. We receive this kind of packet as a result. And as you can see, we have the object counter. And what is very important is the object counter, it's a static, and it is the same, the state, it's the same for all the application, over the application, I mean. Yet meanwhile, if I get this current state, 5.7, it means the next one will use 5.8, and then 5.9, 5.8, etc., etc. So at least we have like, okay, we know currently the state of the counter in this one. So it's help. All right. By sending this first naming service stuff, we get like a counter, but it's not enough. Now, this is where we go back with one thing. Remember the XFA injection at the beginning. This is where, for us, it just resolves everything, you will see. During our test, we test that. Hey, what's about if we, you remember, we find an injection, etc., etc. What if we inject something very long to consume, like this while loop at the right? What's happened? Okay, the request go to the XML form. The XML form tries to generate the PDF. After 1 minute, you receive like HTTP timeout. But we figure out that the XML form still continue to process. So what we do, we send another XFA request. And what is very important to understand is, at this time, Adobe Document Services create a new XML form. It just spawned a new one, because the first one is completely busy. A new one, a new XML form, means a new object key, manager object key. The object manager key we look for. We test locally, we sniff everything, and what we figure out is, if we do this kind of attack, like send a very long XML form to make the XML form busy, and then to send the second one, the object ID of the new XML form, it's the object ID plus 3. So like that, we do not need to brute force the object ID, we just need to have the state, in this example 5.8, and we just plus 3, so we know that the second XML form object ID is 5.8. Very quickly. So object ID, okay. Timestamp. This is a millisecond timestamp. So if you want to imagine it, how many times it will take to brute force, this is few examples. This statistic was made in our lab. So without latency, we directly connected to the system with 20 threads and stuff like that. So for example, if you want to brute force 1 day, it will take 2 weeks. In our lab, so just imagine it over internet, this is completely not realistic. But if we are here, it's because we find a way. So back again to the XFA injection, and back again to the fact that, hey, we are able to make the first XML form busy, like that, all right? But instead of for the second one, instead of sending a normal XML form, we send another injection. And this, in this second injection, what we ask for the date. So yes, we receive a PDF with the timestamp. The timestamp where the XML form, more or less, was created. So if we verify the time before this second request, so on the top, okay, and then we compare, in this case, we have like 4 seconds to brute force. So 4 seconds is like 4,000 requests. And 4,000 requests, it's nothing. So we test all the possibility like that to try to communicate with the manager, the Adobe Document Manager. So we brute force the key like that, and after less than 1 minute, we have the timestamp like that, and we have the object key like that. So yeah, this is how we narrow the timing. And yeah, we have a demo. So the demo, it's quite tiny, but the most important thing it's we just provide the hostname, the IOP port, the HTTP port, and as you can see, okay, we can guess the current counter is B2, so the next one will be probably B5. We have the server ID, and we have the timestamp. The timestamp we receive in the second PDF, and in few seconds, like less than 1 minute, we have the key. And this is the real timing of the video, so it takes this time. Okay, now we have this object key. What we can do? So I let Fabian continue.
Yes, perfect. So after all this way to get to the object key, there was the question, was it really worth it, right? So we did a code review of the manager Corber interface that we were now able to access with that key. And yeah, it turned out that we were now able to do a lot of things. So first of all, there was one operation we were able to call to get access to another interface, which is the data manager. And it seemed like that one is responsible for the shared files you have seen at one of the slides at the beginning of the talk. So to manage that part, it seemed the data manager provided a lot of interesting operations. And using them, we were able to, for example, read any file on the server, but also trigger a server-side request forgery where the application server can reach out to another server and then download a file. And more importantly, we also found an IOR injection. We will see in a sec what this is, directly in the manager Corber interface. We also found some more stuff like leaking information or Java properties. But for now, for today, the most important are the ones in the middle. So to understand what's going on, we have to get back to our overall architecture. And I think what's definitely clear now at this point is that in this entire chain, at the very end, it's the XML form binary which is responsible for rendering the PDF. And that PDF is then returned through all of the web services to the remote SAP systems, and finally it's at the end user side. So when we look at what happens when the XML form process is started, we notice that it calls an operation of the manager Corber interface, which is called register controller. And to put it in simple terms, using that operation, it just announces, hey, I'm listening with my ORB here at this place, and you can reach out to me here. So our idea was maybe now we can just simply do the same on our own and say, okay, we provide an IOR saying that we are actually the XML form on the ORB is actually hosted on our server. So in that manner, we can now actually hijack the entire inter-process communication and get access to all of the application data entered by the users that was supposed to be used for generating the PDFs. And in that manner, we were then able to use the server-side request forgery to upload any file to the server that has then been used into the other direction. So the PDF that is returned to the client is then provided with that server-side request forgery. And this is basically the attack, and it brings us back to our opener demo video, where we will now see everything from another perspective. So first of all, we have the end user again on the left-hand side, which makes use of one of the applications that in the background uses ADS. So everything works as expected, and the PDF is returned. And then what we have on the right-hand side is an attacker's point of view, where there is the upper terminal, just showing that there is no file with an extension out. We will see this in a sec. But basically, we execute the brute force attack now to get that key for the manager Corber interface. And using that key, we will trigger the IOR injection and register a rogue ORB that we implemented with a script in the below terminal. So this is basically our script that mimics the XML form. And we register it now. So you will see that we receive a connection. Yep. And after this point in time, any request intended for the legitimate XML form binary is now redirected to our attacker machine. So here you can see we receive the request and we upload the malicious, so to say, PDF onto the server, and this one is then actually returned to the user. So this is basically how the attack worked from the attacker's point of view. And besides like returning an entire new document, as you can see here, it could also be just like flipping a single byte, right? Or just changing one number. And as you can see here in the upper terminal as well, the attacker now also has access to the data. So as you can see here, this is basically the application data that can now be inspected at this point by the attacker too. All right. So if we now get back to the overall architecture where we have ADS as a central hub system, this of course is something very critical, right? Because it turned out that ADS could be like a single point of failure here, and we found an attack where we can basically take control of ADS, which means theoretically we would now be able to get all of the documents that are supposed to be generated by ADS and that come from all of the different systems in the SAP system landscape. So quite powerful attack. And this is now where we get to the protection against the findings we discussed today. So we reported all of this through SAP's product security response team, who managed the communication and the patch development. And basically there were 2 security nodes released last year. The important for today is the second one, which addresses the XML injection you have seen. Then there is another one capturing different CVEs that we also found in a web service, but we weren't able to talk about today. So this blocks basically the XFA injection and also some more authenticated attacks. But on the other hand side, SAP also referred us to a specific node that describes how you can enable IIOP SEC or IIOP SSL and how you can enforce client-side certificate authentication and disable the plain IIOP port. So this basically introduces an authentication here at this point for the IIOP service. So it's basically addressing the other side of the attack. So these are the 2 measures, and because we hope that you, after this talk, understand that ADS is a critical component, we also wanted to refer to the general security guide that you can find in the SAP Help portal and which provides even more information. And yeah, that's it basically, and now we want to conclude the talk.
Yeah, so we would like to, as a conclusion, we have 3, let's say, sub-parts. The first one, it's, we call it takeaways. The first thing, it's for, let's say, for researcher or for guys who try to find vulnerability, understand vulnerability. It's easy to say, it's like thinking out the box, all right? But what we mean behind it's like, we have 2 examples here. Like the first one, when we found the XFA injection on the first day, remember, we was very excited, but we did not find a way to exploit it. And then we go to the ADS box, and suddenly, in the middle of the ADS study, we have a XFA injection to interact with, and maybe we can use it at this time. So this is the first thing. The second thing, it's the way we narrow the timing of the brute force attack. So just imagine it, what about if we directly inject the date inside the PDF we request? So like that, we can have like a very close to the real timing. So this is why we think. The second point, it's we hope you understand now maybe SAP ADS is something you need to take care. It's a centralized system again, and if some attacker or if it's not secure, it could be what let's say it's not critical, but it's what we call could be a single point of failure. All right. So, and the last thing we would like as a takeaway, it's very important. It's in the mitigation, etc., there are something you need to do. So for the IOP-sec, it's not a default when you install an SAP system with IDS or whatever. The IIOP is in plain text, so you need enable the IOP-sec on your end.
And yeah, so when it comes to future work, I think the first aspect we have to talk about is the IOP interface itself, because in this research, our main target was ADS, right? And it was just like, we bumped into this IOP interface, but it was not like a really deep investigation. We explained some insights today, but we think there's still room for further research into that direction. And then on the other hand side, today we talked about ADS, the on-prem version. There is also a cloud version of ADS hosted in the Business Technology Platform, BTB. And we also found some documentation that there is another ADS version planned on the HANA XSA. These are two things we didn't look at in our work, so we think it could be something for future work as well.
And the last word is what we call for action. So, of course, patch. If you patch XFA, for example, this attack is not possible. Even if the IIOP is still in plain text, the XFA injection is one of the main little, let's say, vulnerability we use. But patch, of course. Again, I know I repeat myself, but this is also what we would like to provide a talk today. It's like you must enable the IOP-sec. This is not a default one, so just enable the IOP-sec. And you are secure. It's like you don't want to use HTTP, you want to use HTTPS. This is exactly the same thing for IIOP. So this is all the reference we use, and that's it for us. Thank you very much.
So, thank you very much. Any questions from the audience? Don't be shy. Anyone? Does not seem to be the case. Okay, so when you do not have any questions, then thanks again for your contribution to Troopers. So we have now, let me check, 7 minutes until the next talk will continue here.